Assalamualaikum warahmatullahi wabarakatuh. Okay, let's look at this topic. Okay, volumes by washer method. Okay, this one is for the cross section perpendicular to the x-axis. Okay, perpendicular to the x-axis. Okay, serenjang. Let f and g be continuous functions on the interval a to b, and suppose that fx is greater than or equal to gx for all x on the interval a to b. Let R here be the region that enclosed by y equal to fx, y equal to gx, and the lines x equal to a and x equal to b. Therefore, the volume for the solid of revolution that obtained by revolving the region about the x-axis is V equal to integrate from a to b pi fx squared minus gx squared with respect to x. Okay. So, for example, we have this type of figure. When we rotate it about the x-axis here, okay, this would be the image, okay, that will for this figure. Okay, so right now, as you can see, is similar to a donut, right? So what we are trying to find for the to do for the volume is we will find the volume for the outer circle minus the volume for the inner circle. Okay, the cross cut here is a circle. Okay, that's why here we will have two circles, which is the outer and also the inner circle. As you can see, this one is V equal to A, integrate A to B, which means here the value here should be the x value y, because we integrate with respect to x. And your function too should be in terms of x. Okay. The first thing that you need to do, okay, this is the axis of rotation. Let's say it rotates at x-axis. That means drag from the axis to the nearest function. This would be your inner radius. Okay. Drag from the axis of rotation or the line of rotation to the farthest area of the region bounded. This would be your outer radius. Okay, that's why here it is actually V equal to integrate A to B pi fx squared minus the inner one, which is pi gx squared dx. Okay, the reason for the pi to be outside is because we factorize. Okay, let's look at the example. Okay, before that, as you can see here, this is a figure. Let's say this is the y equal to fx and this is y equal to gx. This is how it will be done. Okay, the image for the curve being rotated at the x-axis. Okay, as you can see, it is all involve circle. So this is the inner circle and this is the outer circle. Same goes here. Okay, this will be the inner circle and this will be the outer circle. Okay, so next, the example. Let's say we want to find the volume of the solid produced when the region that bounded by the curve y equal to 4 minus x squared and the line y equal to x plus 2 is revolved about the x-axis. Okay, what you need to do first is to find out which one is the outer radius and which one is the inner radius. Okay, and whether you are going to integrate with respect to x or y. Okay, we're going to rotate at x-axis. That means right from the x-axis to the closest function, curve or line. So this would be your inner radius. Okay, from the axis of rotation to the farthest curve. Okay, this would be your outer radius R out. Okay, which means the inner radius here is y equal to x plus 2, right? And the farthest one, the outer radius will be y equal to 4 minus x squared. Okay, since this R is vertical, that means automatically you know that we will integrate with respect to x. So we need to find the value of x1 and x2. Okay, therefore we determine the intersection points. Okay, x plus 2 equal to 4 minus x squared, and hence we have negative, the intersection points are negative 2 and 1. So here is negative 2 and this is 1. Okay, so the outer radius squared. Okay, it's better for you to expand it here so that the integral here won't be that complicated. Okay, so right now the outer radius squared will be r out squared, which is the curve 4 minus x squared. Okay, so 4 minus x squared squared. Hence we have 16 minus 8x squared plus x power of 4. Okay, and then the inner radius would be x plus 2. Why? Because x plus 2 minus 0. Remember, x-axis is y equal to 0. Okay, here is 4 minus x squared because 4 minus x squared minus 0 is 4 minus x squared. And hence this one is x plus 2 minus 0, which is equal to x plus 2. X plus 2 squared is equal to x squared plus 4x plus 4. And then we calculate for v. V is equal to pi. Integrate from negative 2 to 1. Okay, outer radius here, r squared, r out squared. Okay, the one that we have expanded earlier, minus the inner radius squared. Okay, remember, when it involves negative here, like this, make sure the inner radius is written in bracket. Okay, and integrate with respect to x. Okay, first before you integrate, make sure you simplify the equation first. Okay, and then integrate, it will be this one. Okay, this one for the second and the last term I have simplified. Okay, next substitute the upper boundary value minus the substitution of the lower boundary. Okay, and hence we have this value for the volume, which is 108 over 5 pi or 21.6 pi unit cube, either one. Okay, okay, the next example would be this one. We need to find the volume of the solid generated when the region R is rotated about the line y equal to -1 using Gaussian method. So we need to actually draw the line y equal to -1. Okay. Okay, this is actually y equal to -1. So let's draw the line. Okay, this is where the figure will rotate. Okay, we rotate here at line y equal to -1. So now let's find out the radius. Okay, drag from the rotation line, the line of rotation, to the nearest figure, the nearest curve. Okay, that means where the bottom of the region bounded. Okay, this would be our inner radius, and then drag from the line of rotation to the farthest of the region bounded. This would be the outer radius. Since the outer radius here and the inner radius here is vertical, right away we know that v is equal to pi integrate with respect to x. Okay, because the radius is vertical. This would be the value of x1, and here would be the value of x2. Okay, as for this figure, it has been given that the first intersection point is -1 and the next intersection point is 2. But let's say it's not clear to you, you can also find it by using the intersection points. Okay, you have x equal to -1 and 2. Okay, next we want to find the r out squared and r in squared. So here for the outer radius, okay, that means we want to find the distance from this line to this line. Okay, how do we find? Let's say the distance between these two lines. Okay, we want to find the distance of these two lines. That means you will have the line y equal to, let's say, y equal to 7, and here y equal to 4. If you want to find the distance between these two lines, that means you will do 7 minus 4, right? Which is the distance is equal to 3. So the same goes here. That means we want to find the distance between the line and also the axis of rotation. Okay, so the distance is the radius, which is equal to the upper one, the top, which is x plus 1 minus the lower function or line. Okay, here is -1, So therefore, R out is equal to x plus 2. Okay. How about the inner radius? That means here, the curve here, which is x squared minus 1 minus the line of the rotation, which is negative 1. X squared minus 1 plus 1 is equal to x squared. Okay. Here. So the outer radius is x plus 2, right? From here. Okay. I have shown you. So x plus 2 squared is equal to x squared plus 4x plus 4. And the inner radius is x squared, which x squared is equal to x power 4. And here, volume V is equal to pi, integrate from negative 1 to 2. Open the bracket, okay, x squared, this is the outer radius, minus the inner radius. Okay, solve this equation. Okay, simplify, we will have this. Okay, integrate x cubed over 3 plus 2x squared, because I have simplified 4 over 2 equal to 2. And then plus 4x minus x power of 5 over 5. Next, we need to calculate the substitution of the upper boundary minus the substitution of the lower boundary. Therefore, we have the volume, which is equal to 72 over 5 pi, or 14.4 pi unit cube. Okay, that's all. Thank you.